Hey, this is Don from Parallel Technologies again with another video. This time we're going to do a design video. This is going to be about when should you use a load balancer for Cisco ISE. Now, a lot of people, um, they have a nice design that maybe they didn't think through all the way. It really depends on, concurrent sessions. Again, that is very important from a licensing perspective. But once you have the licensing and you know how many machines are actually going to be doing, 802.1x versus, profiling and stuff like that. Now we're going to talk about, a build or when should a load balancer come into play. So we're just going to say load balancing for ICE, right? When should you do it? Okay, so what does that typical design look like? So if you have a two node cluster, you can forget this video. Like there's no point in having a load balancer for a two node cluster. Now, once you start getting into stuff like ice cubes or what they used to call ice cubes, which was, you would break out the admin and monitoring node, or you would break out one node to be admin and monitoring, and then you would have like four PSNs. So you'd have two in one data center versus and two in another data center. Then if you break it out even more, you can have, separate admin, separate monitoring, a bunch of PSNs in one data center, separate admin, separate monitoring, bunch of PSNs in another data center. So that's when you would do your load balancing, so to speak. So what it would look like is, let's say data center one up here, data center two up here, and then we would have, you know, let's say admin. You can do admin monitoring, and then you would have like PSNs up here. So PSN. Now I'm only going to do two PSNs, but if you break out the admin and monitoring, you can add more PSNs. And then right here would be the LB. Right now, this could be F5 load balancer. I know F5's load balancers, net scalers. You can do that as well. I'm familiar with them as well, but most of my experience comes from the F5 load balancer, right? And then when your NADs are set up, so let's have some NADs down here. Let's say we have NADs in other locations. The reason why you would do this or have the LB, I'll just illustrate three, all right? So let's say PSN, 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 PSN. Now, the reason why you would do this is because in your NAD configuration, so we'll just say, switch one, switch two. And this is at the access layer, obviously, all right? That I'm just demonstrating at the access layer. From a NAD configuration standpoint, excuse me, and from a load balancer standpoint, every time you add a PSN to your infrastructure, and this time it would be plus times two. So you do it in the primary and do it in the secondary. You have to go to each and every one of your NADs and add another PSN IP address in there, which from a management standpoint is a huge hassle, right? Because I'm demonstrating four here, but if you have thousands of switches, now you have to go on every switch and add a new PSN to it, even if you were doing something with DNAC or something like that for some automation purposes. You still have to go in there and make sure you add it to every one. In this situation, you would have a VIP. So this would be VIP number one, virtual IP, and VIP number two. And all you would do is send your radius and TACX configuration, or radius and TACX to the VIP, and then the F5 would distribute those amongst the PSNs. Now, the key here is you can add more PSNs. All right, here's three more. You can add more PSNs. You can add as many PSNs as you like, and the F5 is actually distributing amongst all those PSNs that sit behind the load balancer, and you never have to change the VIP on the load balancer. Now, if you re-IP the load balancer, that negates everything. You need to go and adjust every switch with the new load balancer IP. So make sure your subnetting is already ironed out before you even do any of this, right? But in this situation, even if you add, 20 more PSNs behind the load balancer, the NAD never have to add any more IP addresses because they're always going to go here, VIP and VIP. They're never going to go anything else. Now, the one thing that you do have to worry about though is COA, which is change of authorization. When you do COA, you do have to do a technique on the load balancer called SNAT, right? So you have to SNAT it. Same thing on this, right? So basically what you have to say, and obviously you're going to SNAT only for UDP 1700 because that is the 1700. That is the COA port. Now, basically what that means is when I go to send the COA to the load balancer, the COA is going to come back as the load balancer VIP IP. So when it comes back, it's going to come back as the VIP IP. Same thing on this one. Comes back as the VIP IP. Because when you set up the dynamic authorization on the switch, on the access switch, and I believe that is AAA server radius dynamic authorization is the command here. The dynamic author basically is what the command is. That has to have the VIP address in here. So this has to have VIP number 1 and VIP number 2 in there. Right? So that's going to allow you to do things like, dynamic VLAN assignments, pushing DACLs, all that good stuff, right? So you're going to need to have that information here. You know what? Let me move myself out the way here because I noticed that I just wrote something and you can't see it. So let's go up here real quick and we'll just go here. All right. So yeah. So VIP number 1 and VIP number 2 is going to be in dynamic authorization on the switch itself, right? On the access switches itself. Now, there are some things that you do have to worry about when you do this kind of design. One of them is posture. So you're going to have posture and just managing this stuff from the management interface on ISE, right? So you're going to have a rule that's going to make the load balancer act like a router for certain subnets. So your management subnet for posture, because when you do posture, if you're not sending it to a static FQDN, which you probably technically can't, but when posture kicks off and it goes to the whatever PSN it needs to do the posture, you need to be able to get to that IP address, and you cannot NAT that. You cannot NAT that. So you cannot NAT for posture. So when people want to talk directly to the PSN for posture, you have to allow that communication through. So you cannot hide that behind a load balancer, right? There's also things that you have to worry about with guest portals and stuff like that. And you have to use sticky and all this good stuff, or radius sticky stuff, to make sure that you're going to the right PSN and that the PSN that owns the session actually is properly authenticated and authorizing the user. So those are some cons that you have to worry about when you do load balancing. But if you're just doing radius and TAGX and not doing posturing or any of that, you don't really need to worry about that. But this design usually only comes in when you have a bigger ISE deployment. Again, if you just have a 2-node cluster, you do not need a load balancer. That is a waste of time and money. But once you start adding more PSNs, you start breaking out, as I said, you could at a bare minimum admin monitoring, and then you have 2 PSNs. Well, if you don't want to have 4 PSNs in your in every switch that you have, you would do a load balancer, and then you just have your load balancer IP. But once that stuff is set up, now you can start adding more PSNs, right? But it has to be built out correctly. Like if you only want 2 PSNs on each side and you're never going to grow past that, then you can have the admin and monitor node be the same. But once you start trying to add like 10, 20, 30 PSNs, now the admin node and the monitor node need to be separate PSNs. Or separate, they need to be separate nodes, not separate PSNs, but separate nodes. So that's when you would do load balancing for an ISE deployment. Hopefully this video was informative. Don't forget to share, comment, like, and subscribe. If you're trying to get ICE in your environment and you're kind of taken back and you don't know how to design it and you need some help, there's going to be a link in the description for a discovery call. Before you deploy ICE by yourself, you probably should get somebody that has been doing this for a while to look at what you're trying to do so you can avoid some of the traps and problems that you will run into if you build that design, if you build that environment wrong. Remember, I have a video that says great engineering cannot fix bad design. So if you design it bad from the beginning, it's going to be bad at the end. This is Don from Padlock Technologies. Thank you and have a nice day.